This guy here had a question on why when he burns vodka in a shot glass and puts his hand over it, does it stay there unsupported? And I'm bored, so I'm just going to answer it. So first of all, actually, I wanted to address a lot of what people were saying in the comments because it's just not right. So most people are saying, well, you burn oxygen, it gets used up there for creating a vacuum because there's no oxygen or whatever, and therefore it creates a change in pressure, and that's why it sticks. And you're right about the change in pressure, but it has nothing to do with oxygen. Here's why. So we've got the combustion reaction for ethanol. This is ethyl alcohol. This is oxygen. This is a gas. This is a solid. The reaction takes place, creates carbon dioxide and water. But the key thing to note is that the water is also a gas. So superficially, a lot of people are probably thinking you get 3 units of oxygen, then you get 2 units of gas. Well, the water is a gas. If you burn alcohol, there's no little puddle of water there after it. It's given off as a gas because there's a lot of heat release in the reaction. So, converting the ideal gas law, I got the relationship between pressure and number of molecules. And what I wanted to show was that when you burn alcohol, you actually get more gas, so you get greater pressure. So if you think of this as a sealed container, if I put more gas in there, the pressure actually increases. So if you forget everything else, forget temperature and volume and all that stuff, if you were to put your hand over that and temperature and volume weren't a factor, it would actually push back against it. That's why when you've got like a can of soda, you can't really crush it that easily because there's so much pressure of the gas that's in the can. The concentration of gas is higher inside of the soda can than it is out in the atmosphere. So I just did a simple equation here. I just said, well, let's just imagine it's just one atmosphere. Pressure 1 over number of molecules is equal to pressure 2 over number of molecules of the second amount. So you got 1 atmosphere over 3 moles. A mole is just a unit of counting. Think of it as like a dozen eggs. So you've got 3 units of gas, and of course it does not include liquids and solids. They're not included in the gas equation. So on the left side you've got 3 units of gas, and then on the right side you've got 2 units of gas and 3 units of gas. So 1 atmosphere, 3 units of gas. On the other side you have 5 units of gas. So if you calculate the second pressure, it's 1.7 atmospheres. So in fact the pressure is increasing. So that's why that is not right about oxygen. So let's go on what is happening. Because you're right about the change in pressure, but it's not due to oxygen. It has nothing to do with it. So now on to temperature. Most people know the relationship between heat and gas. If I've got a balloon and I heat up the gas inside of it, it expands. That's how hot air balloons work. If I've got a balloon and I decrease the temperature, if I blow up a balloon and I put it in my freezer, the volume of gas decreases. So using the ideal gas law again, I can give this relationship. V1 over T1 is equal to V2 over T2. Volume 1, temperature 1, volume 2, temperature 2. So let's say the gas is 1 liter and at 10 Kelvin, which is really cold, but whatever. If the temperature were to increase to 20 Kelvin, then the volume, solving for that, would be 2 liters. So the volume increased. So everyone probably already knew that, but I just put it on there anyways. So let's go to what's happening in the shot glass. So here on the left I've got basically a picture of the shot glass, and these little dots are supposed to be air molecules, like just the atmosphere. Nitrogen, oxygen, carbon dioxide, argon, small amounts, all that stuff. So it's there. When he lights it on fire, what happens to the temperature locally? It heats up. So when we look over here, we see that the gas molecules are basically going to be the same most of the time because most of the gas molecules are going to be from the atmosphere. But when the temperature increases, the concentration of gas decreases because we have the same number of molecules in here, but they're taking up more space, so the concentration decreases. Okay? So we've got this fire locally. Now these gas molecules are taking up more space because they have more energy. But when he puts his hand over it, then the concentration still remains the same inside of the glass, but then once the heat leaves from the area immediately surrounding the shot glass, then the concentration returns to normal around it. So we've got a situation where now there is less gas inside of the shot glass than there was when that fire didn't take place. So basically what's happening is that inside the pressure has decreased. There is less gas inside of there. So to go back all the way to the top, if there's less gas inside of there, then there's less pressure. If there's less pressure, then what happens is that the atmosphere, since the pressure out here is greater, it starts pushing on the walls of this container. And the reason that it stays up is because the pressure that is being exerted by the atmosphere is greater than the downward force of the gravity. One thing you'll probably notice is, if you've tried this with different things, is that the more surface area for the atmosphere to push on that container, the easier it is for it to stay up. If you have some like really weird irregularly shaped object that doesn't have a lot of surface area, if you try to do the same thing, it'll be harder or it just won't work. So the surface area is important because it's the atmosphere pushing on your hand, and that's why you get that suction on your hand, because it's the atmosphere pushing upwards on your hand and downwards on your hand at the same time.